Hello everyone, I am Lisa Bronner. In just a minute we are going to have a live session on chemistry class. So welcome. I'm just going to be getting set up here while people are joining in. I hope you are ready for chemistry class. Oh, I just remembered something I need to do here. Okay, so while we're getting ready, I'm going to be measuring out some of the ingredients we're going to be using. How many of you liked your chemistry class in high school? I liked my chemistry class in high school. I have come to appreciate chemistry more since I've left high school. I know that all the calculations and formulations are really important, but I would have loved to do a little bit more chemistry that I would encounter in my everyday life. You know, lighting things on fire is really fun. I try not to do that. Sorry, you're hearing my rustly baking soda bag here. Anyhow, so let me know if you liked your chemistry class. And we're going to start in just a few minutes. There we go. Okay, all right, I'm seeing you and I can see your comments. So join on in. Let me know where you are coming from, where you're joining in from, if you are excited about chemistry or you're hoping that I'm going to make it interesting because you've never liked it before. I am measuring out my ingredients here that we're going to be using during our live today. So, yeah, all right. All right, we're going to be talking about the chemistry of cleaning. Okay, so who do we have here? All right, I'm so glad you're joining us. We're going to start in just a minute. Let's see what would be something fun today to share, just to warm up. All right, tell me a time, since chemistry is really close to cooking. Cooking is merely edible chemistry. Tell me about a time where you had a combination in your kitchen that did not go well, which is chemistry in action. So for example, I learned the hard way that you do not add to your tea both milk and lemon. You end up with slightly, white chunks in your tea. So that is chemistry in action in your kitchen. So that's a really fun one. Hey Becky, good to see you. Thanks for joining me. Hope you're doing well today. My neighbor. Anybody else coming from near or far, let me know where you are. All right, just another minute or so and we'll get started. Yeah, so my dad was a chemist by profession and he was a fantastic cook, but he very much cooked using the principles of chemistry and experimentation. He just had an amazing ability to combine ingredients that didn't seem like they would go together. The problem was it was all instinctive and not by recipe, and he could never repeat what he had done. So if you made an amazing meal, you better enjoy it that one time because you might get another amazing meal, but it would never be the same one. So chemistry and cooking, super fun. Today we're only going to talk about chemistry and cleaning. All right, I'm going to go ahead and get started with our topic for the day. So welcome. My name is Lisa Bronner, and I write the blog and social channels Going Green with Lisa Bronner. And I love talking about all the ways that we can keep things simpler, safer in our everyday lives. I very much like understanding what's going on. I don't like taking advice because somebody said to. I really like knowing the why. So our topic today is the questions that I have asked over the years. What is actually happening when we're cleaning our house? So I've learned that there's so much going on that we cannot see. That when two substances combine or mix and they might look like they're just sitting there, there is so much happening on the molecular level. And that's pretty much what we're going to be talking about today. Now, I am giving you a shortened form of a presentation I just gave at the Dr. Bronner's headquarters last week on Earth Day. I always have so much fun every year presenting something to our staff, and over the years I kind of think, what have I not talked about? So this year we went back to chemistry class, and it was really fun. That was a longer presentation. I'm going to give you like the shortened form. So cleaning. What is happening when we clean? What is happening that makes things safer, cleaner, prettier when we're working around our house? And then this maybe will give you something to think about when you're cleaning but you're bored. So cleaning. There are 3 ways that we really clean our houses. There are other ways to clean, but these are the 3 main ways. The first is mechanical cleaning. Mechanical means movement, literally moving things. So think when you dust, when you vacuum, you are literally moving dirt and debris off of the surfaces. Your air filters, any sweeping, you're literally moving. That's mechanical cleaning. And that's always the first type of cleaning. Because if you have like literal debris on your countertops, on your floors, you don't want to jump to chemical cleaning because you've got all this stuff in the way. You need to get that stuff off. And that stuff really can hold a lot of junk in it, a lot of germs, a lot of chemicals even, a lot of particles from our fabrics, from our furniture, from our pets, from ourselves. So we always want mechanical cleaning to be the first thing. I don't know if you all can hear my dogs. I have 3 of them today, so they'll go outside. Okay. The second way we clean our houses is with heat, thermal cleaning. Yes, you can clean with ice, but for the most part, we clean with heat. And this would be cleaning that we might do in a self-cleaning oven. If you utilize that feature, you're using extreme heat to blast everything off. They get up over 600 degrees. They might even get up to 900 degrees. They're literally just burning the stuff off. It's not really fancy. And I'm not going to go into whether that's good or bad. But thermal cleaning, if you use a steam mop or a steam grout cleaner, you're using heat and water, but heat is one of the key components of those devices. And then, of course, a doctor's office is going to use heat like an autoclave to sterilize things. We don't use heat a whole lot around the house, but sometimes. When people think, oh, if I wash my hands with hot water, they'll get cleaner. Honestly, not really, because the amount of heat it takes to kill germs is so much greater than our skin could withstand. Warm water might help if we have, I don't know, oil on our hands, but it can also strip the oils out of our skin. So anyhow, so heat isn't something we use a whole lot, but a little bit. And then there's a third way, and this is what people usually think about when we talk about cleaning, and that is chemical cleaning. And by chemical cleaning, I mean any type of cleaning that uses the principles of chemistry. I don't just mean toxic chemicals or dangerous chemicals, any chemicals. So soap, which I have right here, this is a chemical cleaner. It is cleaning through the power of chemistry, laws of attraction, and all of that. Other perfectly common chemicals per se in our green cleaning cabinet might be vinegar, alcohol, hydrogen peroxide. All of those are using the principles of chemistry to clean, whether they're a solvent like alcohol or whether they're using some other soap is actually an emulsifier, technically speaking. But those are chemicals. And then, of course, we do have our more high-risk type of chemicals that are all too common, your chlorine bleach, your ammonia, or drain cleaners use sodium hydroxide. Those are chemical cleaners, but they certainly can be misused and can expose us to harmful things. So chemical cleaners are what I'm going to talk about today, and the chemical cleaners that you might use in your green cleaning. You might think you're doing a great job with green cleaning, but there's chemistry happening, and so I wanted to talk about a little bit about the chemistry that happens when we clean, even when we green clean, just so that you can understand what's happening, what not to do, and how to take advantage of the power of chemistry. So I hope you like chemistry, because that's what we're talking about today. So I'm going to show you 2 combinations, and I want you to watch them combine, see what happens, and does something happen, and then I'm going to tell you what's happening or not happening. And then we're going to use these principles to make one of my favorite DIY green it yourself recipes, which is the soft scrub. So let's start with one of the combinations that got me started with my blog. So when I started my blog back in 2010, one of the reasons I wrote it was to address some common mistakes people were making in their green cleaning. And I was doing this on behalf of my family's company, which is Dr. Bronner's, because it was kind of making our products look bad. So our flagship product is the Castile soap, magic soap, peppermint, which is the blue label. People were combining it thinking they were doing like really great, safe cleaning, but they were causing some chemistry to happen that would not be helpful, and that could make it look like our soap was the problem, and it really wasn't. So this was the reaction that got me started. So I'm going to put some soap here in this glass. Chose just a clear glass so you can see it. So all right, you see our soap. It is this amber color. It's got some air bubbles in there, but that is our soap. And then I'm going to take the other hero of the green cleaning cabinet, which is white vinegar. I use a lot of white vinegar. This is actually a pretty small jug for me. I usually buy it larger. And this was the combination. And it was talked about on Oprah. Some very well-meaning person was talking about how they safely clean their house, and they talked about this combination. And it was great like publicity for the soap, but it wasn't, because if anybody did this, they would be really disappointed. So I kind of gave away that something's going to happen here. Okay, so soap and vinegar, watch. Okay, you see? Yep. Okay, watch. Ooh, okay. So if you can remember back to your chemistry class, the first thing you do is hypothesize. We kind of skipped that part. The second thing you do is you observe. Now, if you observed, did something happen? Yes, something happened. We put in a clear yellow or golden substance and a pretty colorless substance, and we ended up with something kind of milky and opaque, white. All right, so we know that something happened. That is a reaction. There was a chemical reaction that happened between the soap and the vinegar. Now, what happened? So this is something, I don't know if this is actually a word. I know that spell check would flag it, but sometimes they don't have chemistry words in there. I call this unsaponified, the soap. So saponify is the word that means to make soap. Unsaponify means to unmake the soap. So vinegar is an acid. It's acetic acid. It has a pH around 2 to 3. Soap is an alkaline. It's a base is another word for that. It has a pH around 9 to 10. And acids and bases very often react with each other. And that's what happened here. The acid and the base reacted with each other. The acid broke apart the base. It broke apart, the vinegar broke apart the soap molecule. So we don't have vinegar and soap. The reason there's still some soap is just because of the amount. I didn't add enough vinegar to react with the whole thing. And so we no longer in this layer have soap and vinegar. We have something completely different. So you don't have the cleaning power of soap. You don't have the solvent power of vinegar. You have something else. And if I know you can't touch it, but go do this experiment, then you can touch it. This is like, well, you can see the chunkiness on my hands. It's oily. If I tried to rinse this off my hands, I would still feel oil on my hands. This is not going to clean anything. So that's not very useful. All right, so that is reaction number one. The second reaction I want to show you, the second combination I want to show you, is another hero of the green cleaning cabinet, and that is baking soda. All right, so baking soda. Okay, so it's simple, what we use to cook, what I use in my laundry, or to scrub things, or to deodorize my carpet. I use baking soda. So is baking soda. Okay, so once again, I'm going to put a little bit of soap in my clean glass, new glass. All right, and then I'm going to put some baking soda in here. Can everybody see? Okay, now baking soda is already a white powder. So if you can kind of see, it's still a white powder. It's sitting there, You're just seeing the white powder in there. It's not doing anything. You have soap, you have baking soda. They're not mixing, they're not combining, they're not reacting, they're not making anything new. I'm going to stir it up to encourage it. You remember in chemistry class, sometimes you stirred things, sometimes you heated things. So I'm stirring it. And I made some bubbles just because of the soap itself, but I still have baking soda and I still have soap. So baking soda and Castile soap, or true soap, do not react. They work side by side. You can use them together. You still get the cleaning power of soap and you still get the scrubbing power of baking soda, and so those two do not react. Now the third combination we're going to do. All right, I'm going to grab another glass. Okay, bigger glass. Bigger glass. Okay, here's what we're going to do. I'm going to take a little bit more baking soda. I'm going to put it in my glass. This time I'm not going to use soap, baking soda. And now I'm going to put some vinegar in here. Now, probably all of us went through 8th grade science, so you know what's going to happen here. Okay, so baking soda, vinegar. Okay. Ah! Oh, whoops. All right. That reacted. Okay, there we go. Woohoo! Little too much baking soda and vinegar. I underestimated how much that would react. All right, what happened? What happened there? We have this reaction between baking soda, which is a base, it's an alkali, and vinegar, which is an acid. They react very fast and very readily. Actually, the glass just became cold, which if you cast your mind way back, that means that the reaction, you can either have an endothermic reaction or an exothermic reaction. That's an endothermic reaction, which means it took in heat. And so we definitely know that there was a reaction there. Now here's the thing, baking soda and vinegar do react. I see a lot of recipes online that call for combining baking soda and vinegar. It's a completely harmless reaction, and it actually doesn't even, other than overflowing my glass, it doesn't even make a very messy reaction. It's not like the soap and the vinegar. However, it's not a very useful reaction in general, because what do we now have? We had sodium bicarbonate and acetic acid. We now have left after the reaction, it makes water, carbon dioxide, which was the bubbles, and something called sodium acetate. None of those are cleaning agents. Well, I mean, water is, but it's just water. Sodium acetate, it's still a little bit gritty, so it might be good for scouring. But it's not like a soap or even a detergent. It's not going to grab hold of oil and clean it off of surfaces. So it's not the most useful reaction. It's not something I use very often. Okay, so those are 3 reactions, or 3 combinations. 2 of them reacted with each other, 1 of them did not. And I want you to keep all of those in mind as we make soft scrub. Soft scrub is just chemistry in action. I love this recipe. So what do we have here? I have 1 2/3 cup of baking soda in my bowl here. And to that, I'm going to add a 1/2 cup of Castile soap. Let me get rid of the... All right. Okay, so I'm going to add 1/2 cup. Yes, I know that's a dry measuring cup, and I'm measuring a liquid, but it's not actually needing to be that exact at this point. Okay, so 1/2 cup of Castile soap. And as we just saw, these aren't going to react with each other. It's just baking soda and soap. They will mix, like I'm going to mix them, and they're going to form like a kind of a crumbly mixture, but they're not reacting, they're just like coexisting. So nothing too exciting. And then once I have these mixed, I'm going to add some water, because you can tell it's like kind of a crumbly mixture. I want it to be a little bit liquid. So I'm going to add some water to that. All right, here's my water. I'm going to add another 1/2 cup. Now this recipe, I put a link in the comments to the website, my website, where I have this recipe. It's a bigger batch, but it's the same recipe. Okay, so I've added the water. I'm going to stir that up. Anyhow, so you can go find the recipe. So once again, nothing is happening. Water does not react with soap. It doesn't react with baking soda. So I now have 3 things in here. All right. Okay, now is the time for the quiz. I'm going to see how well you were paying attention. Okay, so that's just it's foamy because of the soap, but there's no reaction. Okay, so that's all mixed. Now, here's where I'm going to see if you were paying attention. I'm going to add some vinegar. Now, you should have some red flags going off, some little lights going off in your head. Wait a second. I have soap, baking soda, and baking soda in this bowl, and we just saw that vinegar reacts with both of them. How is that possible? Why am I going to do this? Okay, here's the thing. Chemistry has an order of operations. So with chemistry and with vinegar, vinegar does react with both baking soda and soap. However, it reacts faster, you probably saw that, faster with baking soda. We're going to take advantage of that. It's going to react with the baking soda in my mixture really fast, and it's not going to have a chance to react with the soap because the baking soda is going to use it all up. But why am I doing that? I just said that baking soda and vinegar don't have any cleaning properties. That is true. The reason I'm doing that is because this is soft scrub. We use soft scrub to clean vertical surfaces. Let's say your bathtub or your shower, your grout, your tile. You want it to stick inside of your toilet. And to make that texture that will cling to vertical surfaces, we want that foaminess. So we're actually going to add the vinegar to react with the baking soda because I want the bubbles. I want to capture those bubbles. And the soap is going to hold, it's not going to let that carbon dioxide evaporate out. It's going to hold onto it by making bubbles because it's soap. So I am going to add merely 2 tablespoons. Okay, I don't have enough hands here to show you the reaction. Well, here, let me see if I can do it. Okay, so I have a tablespoon of vinegar, and I have my soft scrub. Can you hear that? Oh wait, where's my microphone? All right, I don't know if you can hear that. Okay, so that was 1 tablespoon of vinegar. I'm going to add the second one. Okay, I want you to see. Okay, it is bubbling, and that's what I wanted because it's the bubbles that make the wonderful texture of the soft scrub, and it's the soap that's going to capture those bubbles and give us our texture. Okay, so that's chemistry in action. We took advantage of the order of operations. We wanted the chemistry of soap, of vinegar and baking soda. We wanted the release of carbon dioxide to make our bubbles. And then the soap is just sitting there ready to clean something, and the vinegar hasn't messed with it and such. So what am I going to do with this? I'm going to take this, and I've got an empty bottle here, and this is really pourable. I'm just going to use a funnel to put it in my bottle here, and then it's ready to be squirted onto vertical surfaces in my bathroom, my toilet, to clean. Now here's the thing. With green cleaners, or homemade cleaners, one of the biggest differences is shelf life. Stuff that we buy at the grocery store, at the store to clean, usually has months, if not years, of a shelf life. Homemade cleaners don't have that stability. That's part of the good thing. We don't add stuff to it to give it that stability. All that to say, I did an experiment where I left the soft scrub sit for several weeks, and I don't know whether or not the water content just evaporated or there was some residual chemistry happening, but it got pretty hard. It really formed a paste, which is still useful, but it doesn't squirt out of a bottle very handily. All that to say, go clean with the soft scrub. Don't let it sit in your cabinet. It's meant to be used. All right, so oh, and Henry, I see that you had just asked that question, so I actually hadn't even seen your comment, but yes, okay, I hope that answered your question. If anybody else has any questions about the soap or chemistry of cleaning or anything else, I am happy to answer them. Let me scroll through here, see if I missed any questions. Okay. Oh, good, Christy. I'm glad you got your hands on the cherry blossom soap. So right now it's April 29th. We are at the very end of our limited release of our cherry blossom seasonal scent of the Castile soap. When it's gone, and some of the sizes are already gone. This morning, we still have the gallons, the bar soap, and I think the refill container and the lip balm, but they were going fast. So if you want to try the seasonal scent of cherry blossom, better hop over there now and you can try that out. But if you miss it, you're going to have to wait until next April. We will be releasing the green tea and sandalwood jasmine later this year. So if you want to know when that is, subscribe to my newsletter over on my website. So my website is lisabronner.com, over on Going Green with Lisa Bronner. And then if you really like this chemistry, I highly recommend my book, because I love talking about chemistry. I want you to know why stuff happens, and my book, Soap and Soul, talks about that. So you can learn lots and lots. If you think of a question that